It is 10:30. I'm gonna get started and just do double check, make sure the recording is up. It is. There are one main thing I need to do today, and then the rest depends on how much time we have. After we get that part done. We have the first exam questions. It's a mock exam. So these questions we'll go over today. I just came up with these, earlier today, so none of you probably have seen it at this point. But that means, the actual exam is in 1 week. So next Monday we'll have our first exam. Okay, the exam will take place in the classroom. I'm not sure whether we want to make it a paper exam or whether we want to take it on the computer. It depends on whether we have enough computers. If we do not have enough computers, we'll take it on a piece of paper, which makes grading harder for me because I have to collect all the paper and then do all the gradings on paper. If we do it on the computer, we can do it in the classroom, and then we can we can make the quiz an online quiz in that case. But I haven't decided yet, which way to go. But before we get to the first exam, the mock exam, let's see if we have any questions about find maximum, the homework assignment. How many people have at least gotten started with this one? Okay, and let's see. I can tell how many people have turned it in. So 15 people have turned in, combining from 2 classes. So that's pretty good. That's not bad. Are there any questions about this particular homework assignment? No questions? Yep, go ahead.
Well, and this is probably just me, but when I tried to actually access the code and the file and all that, it wouldn't let me.
It would not let you.
Yeah, I tried to unzip it, but just, I don't know, it just wouldn't, it said it couldn't do that command.
Are you doing in Linux or in Windows?
I'm doing it in Linux.
Did you use unzip to unzip it? There's a command called unzip.
Yeah, I tried doing that, but it just, I tried to do it for my downloads, but it wouldn't. It said it couldn't do it.
In the virtual machine?
Yeah.
What does it tell you exactly? I mean, I need to know the message.
I can't remember word by word, but.
Okay. Well, do it again, but this time use your phone to take a screenshot, or do whatever you need to take a screenshot of it and send me the screenshot, so I can at least know the message coming back from the system.
Okay.
Yep. Okay. Any other questions regarding the homework assignment? Find maximum. No questions. Well, if there are no questions about the homework assignment, we'll go ahead and talk about the mock exam. Yep.
So you just actually find the biggest number, right? You don't actually find the sum of the whole thing or anything like that.
It's the maximum, the largest of the 4.
I actually had to watch the video in order to figure that part out, because there was one time when you said that, and I was thinking, yeah.
Huh?
And,
Okay.
It does make sense, 4 numbers.
Yeah, find the maximum of the 4. But it doesn't have to be unique. In other words, if I give you 4 numbers and they're all the same, that means every single one of them can be considered the maximum. Okay? All right. So if there are no questions about find maximum, which is due on Wednesday, that's right. Okay. So if there are no questions about that, I'm going to move on and talk about the mock exam. There are 4 questions I have made up at this point. And we'll just go ahead and go over each one, one by one, because there are 2 things I want to go over, with this one. One is what type of question I might ask, and 2, how do we answer those questions? What am I expecting for each type of question? This is question number 1. So it starts with a particular snippet of code. It's not an entire program. In other words, if you just type it in, it's not going to run. The question is here. There are no indication to help or confuse you here, because I basically do not use indentations whatsoever. Answer the following questions. If you think this code has a syntax error, assuming x, y, z, and k are all declared as integers already, state why there is a syntax error, and 2, how to fix this syntax error. Okay, so let's go ahead and check that first. Okay, so we pretend that we are the compiler, and we encounter the word if. when the compiler encounters the word if, it will expect 1, 2, 3, 4, 4 things. Open paren, an expression, close paren, and a statement after that for the then statement. Okay. Optionally, can also expect an else keyword after the statement, and then an else statement after the else keyword. Okay. So from the perspective of the compiler, right after it sees this close parenthesis, it will say, okay, I need one statement here. But when it's expecting one single statement, it sees the if of a conditional statement. So now this entire conditional statement becomes the then statement of the earlier if statement. Okay, but this particular if statement has its own expectations, right? So it sees the if here, it expects open parenthesis, it's here, expects an expression, it's here, expects a close parenthesis, and it's also here. And at this point, the inner conditional statement starting on line 2 says, okay, I need one statement as the then statement of this particular conditional statement. And what does it find? It finds k equals 1 and a semicolon. That is what we call an expression statement, because it's just an expression with a semicolon after that. So that fits the requirement of a single statement. It's fine, it's cool, okay? But then after that, it also finds an else. So here, the biggest question is, whose else are we talking about here? Is this the else of line 2, or is this the else of line 1? Else of line 2, okay? Because matching an else with an if is kind of like matching parentheses. Okay, when you see the first closed parenthesis, it will close the first unclosed open parenthesis. In this case, this else is associated with the first unclosed conditional statement, the innermost one, the most recent one, which is line 2. So once we see this else here, we're saying, okay, this if has an else portion. And after else, we are also expecting one single statement. And that one single statement turns out to be another assignment expression statement, which is fine. Okay. When the compiler sees this particular semicolon, it knows it has done one entire conditional statement, which is the then portion of the conditional statement that started on line 1. After the then statement of a conditional statement, what is optional? What can happen? Else. That's right. So the else of line 6 is the else corresponding to the if of line 1. Okay? And what do we expect after an else? A single statement, right? And what do we see is the keyword if. So that means the else branch consists of one single statement, and that one single statement corresponding to the else branch of the if starting on line 1 is starting on line 7, which is by itself also a conditional statement. So once again, we start parsing a conditional statement. If, is the keyword here. We need open parenthesis. We need an expression in the inside. We need a close parenthesis, and then a statement after that. And that statement is just this guy here. Okay, so that's fine. Syntactically, we don't have a problem. And then after that, we also have single else, which if is corresponding to this else. The one that's starting on line 7. Very good. And after else, we have a single statement. We're expecting a single statement, which is actually line 10 here. Now this one is kind of funky because it displays a 0 instead of 10. If you use Firefox, it would actually display 10. If you use Google Chrome, it just displays a 0. I think it has to do with how they treat the cascading style sheet. The styling is the same on both browsers, but they interpret the styling differently, and on Chrome it is not displayed correctly. But if you use Firefox, it will display correctly. Okay, so when we see this when we see this semicolon, it will basically finish the else statement of line 7. But line 7, starting on line 7 all the way to line 10, this entire conditional statement is the else branch of the if starting on line 1. So at this point, we are done with the entire program. So there are no syntax error with this particular code. Are we doing okay so far with analyzing the program, kind of from the perspective of a compiler? Yep.
So it doesn't have to be indented. That's just for our.
Indentation is entirely for human consumption.
Okay, but there's another yay that's equal to like 2, then unless you have the curly braces, then it wouldn't count that fourth line.
Then we will have a syntax error in that case. If you have one more line between line 3 and line 4 here that says that is another expression statement, but without the use of any open curly brace and closed curly braces, then it will be a syntax error. Because by the time it gets to else, it doesn't know whose else we are talking about anymore. Right. But that's not the end of this question, okay? Just knowing that it is syntactically correct is not the entire question, because so now we have to deal with this part here, because we do not think the code has a syntax error. So now we have to answer the other part. Indicate the lines in order of reaching when this code runs for each one of the following cases. I know this is kind of confusing. What it means is use this as a test case and show me line by line how this code is going to execute. That's what I mean. Okay? So what you need to do as an answer, which I will do here using a text editor, is to show you what I'm expecting as the answer for the first test case. So what I'll do is to say, okay, this is our first test case. X has a value of 2, Y has a value of 3, and Z has a value of 4. So now we go back to the first line here, and we say, where do we start? Well, we always have to start with line 1, right? So we start with line 1. And then where do we go after line 1? In other words, is X less than Y? Okay, X is less than Y, so we have to go to the then branch of the conditional statement starting on line 1, which is the outermost conditional statement. So which line do we go next? We go to line 2. And line 2 is saying, is Y less than Z?
Yes.
The answer is yes. So where do we go next? We go to line 3, and then where do we go next?
Wouldn't you want to replace the, because they're okay, so okay, never mind.
Okay, so after line 3, nope.
What's
We're done. No more. Lines 1, 2, and 3 is the correct answer. Okay? Optionally, the only option I can take here is basically whatever is after line 10. If you add it here, it will still be considered okay, because we execute line 1, we execute line 2, we execute line 3, and then we are done with this entire thing. Okay? So the continuation will basically continue with whatever is after line 10. If there's nothing after line 10, we are all done. Is that part okay?
Mm-hmm.
Because a conditional statement is either going this way or the other way. But once you take one side of the branch, you never go back to the other branch. It's a one-shot kind of deal. Are we doing okay so far of why it is just lines 1, 2, and 3, and then we're all done? Okay. Let's move on to the second test case. The second test case is, what if X equals to 2, and Y equals to 2, and Z equals to -1. That's my second test case. So with the second test case, I have to do exactly the same thing, analyze what the program is going to do line by line. Line 1 is a given, right? Go ahead.
Wouldn't it just stop?
Huh?
Because doesn't have an equal sign
Doesn't have a what?
on either 1 or 2. The first two lines, there's not an equal sign, so
It doesn't matter, right? X is less than Y is not stating X is in fact less than Y. It is asking, is it true or is it false that X is less than Y? There's always an answer to that question.
but they're like equal.
The answer is false.
So the answer is false, exactly. When you see in a program, when you see something like this, it is not stating X is in fact less than Y. It is just asking, is X less than Y as an expression? Is the value of the expression true or false? If it is true, go here. If it is false, go somewhere else. That's what a conditional statement does. Okay. So in this particular case, X has a value of 2, Y also has a value of 2. I still have to start with line 1. So line 1 has to be here. But instead of going to line 2 because x is in fact less than y, where are we supposed to go now? 6 or 7 are both considered correct. Okay. People who took cisp360 from me would answer 7 because I don't trace line 6 as an else statement. But since not everybody came from my class, my cisp360, I will count line 6 or 7 both as correct. Okay, 6 is kind of optional, so I would basically put 6 as an optional here, and then line 7 is what you need to write down as an answer. Okay, when I use square bracket, it means it's optional. Okay, if you write down line 6, I would not consider that incorrect. But line 7 is what I need to see, because line 7 is the beginning of the else branch corresponding to the conditional statement that starts on line 1. Alright, so now we are on line 7. Line 7 is asking a question. Is x the same as y?
Yeah.
The answer is yes. So where do we go after line 7? Line 8. That's it. So technically, I only need to know 1, 7, 8, and that will be considered as a 100% correct answer. The reason why line 6 is optional is because line 6 really doesn't do a single thing. The purpose of line 6 is only for the purpose of the compiler, to separate the then branch from the else branch. That's all it's doing. It's kind of like a comma, it's a separator. Okay, that's its only purpose, is to separate the two branches. But in execution, it really doesn't do a single thing because there's no assignment statements. There's nothing to perform on that line. So that's why line 6 is optional. I would not count it wrong in this class. Are there any questions about the answer to the first part of the question? Yep.
So if we were given this code with one of the semicolons missing, then it's syntactically wrong.
Yep, it is syntactically wrong because without any one of these colons, then you have an expression, but not an expression statement. And because each branch needs to be a statement, if you only have an expression, it will count it wrong or syntactically incorrect because it is not a statement anymore. Or if you have one semicolon too many, it will still be wrong, right? So if you mistype it and use double semicolon instead of one single semicolon, to a human eye, it's like, oh, that's kind of redundant, right? No big deal. To the compiler, it's a big deal, okay? Because when you have two semicolons, then you are closing the conditional statement. You're basically saying, do not expect an else anymore. We are done with this conditional statement.
So if you wanted to shortcut the if-then statement, would you use double semicolon?
At the right place. Yes. Okay, so that answers this part of the question, and now we have the last part here. Yep, go ahead.
Sorry, just to clarify the code you had there. So if the first one is false, so what we found here it was false, then we skip the if, the else, and we go to the next else, right? Because as soon as it's false, the computer expects an else.
Okay.
Right after that, it doesn't expect anything else.
I'm not sure whether in this class it's good to use App Inventor, but that's one really kind of cool graphical way to display the nested structure of this code here. So I'm going to try that and see if it helps. If you guys think it's not helping, then I would use another way. Okay. So I'm going to go to App Inventor here. I know this is not cisp362, but I think this might be helpful. So I'm gonna try. I'll give it a try. So I'll try. This is exam 1, question 1, and we'll just go ahead and go to the blocks here. I don't need to execute a code. Well, actually, I think it'll be fun to execute a code too. So let's go ahead and do that. So now I'm digressing more and more from what this class is about. In a way. Okay, so we'll have 3 text boxes here for X, Y, and Z. So we have text box 1, text box 2, One is x, y, the other one is y, x, y, and z here. And then we have one label so that I can reflect the value of k afterwards, and a button to trigger the entire operation. Instead of naming these things as text box 1, 2, and 3, let's go ahead and rename it. So it's text box for x, text box for y, text box for z, and then the label, it's just basically the label of value of k, and then the button is just a button to trigger the operation. So we just say do it, and change the text here to say exactly the same thing. Do it. There we go. All right. So to specify what to do when the button is clicked, I will basically use exactly the same logic as in this code here, except in this case I'm going to use like a more graphical representation, which will clearly indicate the ordering of things. Okay, which condition is checked first, which one is checked second, what is the else branch, what is the then branch of each one. Okay. All right. So getting back to App Inventor here, and we'll go to the blocks view. Okay, in App Inventor, blocks view is showing you the actual code. The other one is just the design of the application. So we'll go to button do it and say when it is clicked, then we'll trigger the logic. So now it is time to specify exactly the same logic here, but except in this case we're using a drag and drop way to draw something. But the point is the nested nature of this whole thing will be very clear, because we are seeing your blocks like this is an if, this is a then, and this is the else. Okay, so we go to control and we say, okay, let's go ahead and start with a conditional statement. And in this case, we do have an else block here, so that's why we're dealing with a condition, the then statement, and then the else statement. Switching back to the original code, the condition is when if x is less than y. So we'll go ahead and specify that in App Inventor. Okay, I'm gonna do it the lazy way. So I'll just go ahead and use comparison. This is the less than symbol, and then we'll say text box x. The content of text box x is the text in text box x. We put it here. If it is less than the content of text box y, then we have, this is the outer conditional statement. Is that part okay? Okay, now we have to specify the then branch of the outermost conditional statement. Switching back to the original text code, the branch of the then branch of the outer conditional statement is going to start from here and it ends over there. In other words, it is by itself a conditional statement, and the condition is if y is less than z. So we're going to do exactly the same thing in App Inventor. Go to control, specify another conditional statement that is inside of the first one, and then we'll just go ahead, replicate this whole thing, except this time we are comparing y to z. Is that part okay? Yep.
Now, since this is a graphical way of doing this code,
Yep.
couldn't you have just copied the if-then block instead of having to go search for it and then drag and drop it again?
Yeah, you can do that too.
So like just right-click on it and copy.
Yep. So in this case, I can duplicate the whole block
Okay.
and put it into the else, but I have to change the else to be comparing y to x to y, and we're checking for equality. So if we go back to App Inventor, then we'll switch the relational operator to equal to, and then this time we are comparing x to y and check for equality. We doing okay so far with this code? Yep.
Yeah. Do you need to use App Inventor for the now?
No.
Okay.
I'm just using this, just so that people can get a kind of more or less graphical view of how the code is structured. Okay. So this is how it's structured. We have 3 conditional statements. One is the outermost one, and then each branch of the outermost conditional statement, each branch, the then branch and the else branch, they are both by themselves, also conditional statements. Okay. So K is getting the values in here, 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 and here. The text representation is going to 1, 2, 3, 4. So I'm going to do the same thing in the graphical representation here. So we go to variables, and then we just have to set our global variable to that number. We don't have a variable. We have a label to do the same thing. So we basically say set label K text to 1, 2, 3, and 4. So we'll specify this to be 1, duplicate it, change it to 2, duplicate it, 3, and one more time, set it to 4. Okay. This is the graphical representation of what we have here in a text representation. Are we doing okay so far with this concept? Looking at the text portion and then look at the graphical representation and kind of say, okay, these two are representing the same logic, even though the actual representation are different. Okay, the question now is, so in this case, how is it going to run? I mean, how do we know that the program is traced correctly and it is executing in the order that I specified earlier? So this will be a good time to start up an emulator, and so we're actually going to run this code in App Inventor. The other thing you can also do, especially since this is a mock exam and you can definitely do it with a compiler, is to finish the entire program. Just add the definition of main as a subroutine, declare the variables x, y, z, and k, and then use GDB to help you track down how the code executes. Okay, so that's the other way to answer that question. Uh-oh. Yep, go ahead.
How long is the exam, and how much time are we given?
We have the entire class duration, so that would be from 10:30 to 11:45. So we have, 75 minutes?
And how long is the exam itself? How many questions?
I would say about 4 questions or so. I haven't decided yet. Let's do it again. There we go. As the emulator is starting up, we can take a look at the second part of the question. The second part of the question is, not knowing the exact value of x, y, and z, indicate as completely as possible how these 3 variables relate to each other if code execution reaches any one of these lines. So treat each one individually. If we ever get to line 3, what does it mean? How do the variables x, y, and z relate to each other? Tell me as much as you possibly can. If we get to line 5, what does it mean? If we get to line 8, what does it mean? If we get to line 10, what does it mean? So this is about the analysis of the structured code here. It is not asking you to trace it. It's basically saying, okay, if I get to a particular point, what does it mean? What do I know at that point? Okay, and we'll answer that question as soon as we get the other portion out of the way. Okay, so this app is, I think it's starting with this one. Because I thought, oh, maybe I didn't change this. Okay, never mind. Okay, so this is the actual app running, and let's go ahead and plug in the numbers, right? Give it a try. So the first test case is 2, 3, and 4 in x, y, and z. So let's go ahead and put it here, 2, 3, and 4, and then do it. And we end up with the 1, which is correct. Because we executed line 3, and line 3 puts a 1 into variable k, and that's reflected here. The second test case is 2, 2, and negative 1. So let's give that one a try. 2, 2, and negative 2. And we will do it, and it gives me a 3, which is line 8. So if you compare this to the execution here, 1, 7, and 8, the point is, we got to line 8. Okay. Yep.
So this test, is it going to be, like, are we going to do it online, or or is it?
I have not decided yet, because with this section here, we have more students than there are computers. So that means if I cannot guarantee each student to have a computer, it's better to do it on paper, so that we definitely would not have a problem, would not have an issue. Yep. I don't want people to share the same computer when they're taking a test. Yeah.
If we're given this particular code, are you going to ask us a question like, given that x is 2, y is 3, and z is 4, will you ask us what's going to happen at line 3, or when you get to line 3, or will it execute? What is the value after line 3 executes?
In this particular question, I just ask, what are the line numbers? So I'm not asking you what are the effects of executing each line. I'm just asking you, in what order will I, reach the lines? So in this case, it will go to line 1 first, line 2 second, and then line 3 is the last one. After line 3, we are done with this conditional statement. So whatever we do is going to be out of this entire code after that point. Okay.
So line 3 or 3 would be the answer.
1, 2, and 3, both, all of that.
Right.
Because it tells me, it asks you to indicate the lines in the order of reaching them. So we reach line 1 first, and then we get to line 2, and then we get to line 3. But after line 3, we get out of the inner conditional statement. We also get out of the outer conditional statement. So after line 3, we are done with the entire code. Okay, so question.
Sorry, before you change that. So my question, I can follow the code. Okay. My question is kind of okay. So after the first one, line 1 is false. The computer or the program knows to go. The compiler knows to go from if, because it's false, has to go and find an else first, right?
Go to the else branch.
Now, does the computer not just keep the first else and go to the second one because the else for the first one, without even having the brackets?
That is correct, because the compiler understands the structure of the program.
Okay, so it knows that it's another if. Okay, so that was kind of my question.
Yep.
The compiler knows how to split it up.
Right. Yep.
So we don't ever put pre and post on.
No, we don't do pre and post here because not everybody came from my P300, so I cannot make that assumption. So you guys can relax a little here. The rest of the class are asking, what are pre and post? Well, fun stuff, good times. Any other questions? No? Okay. So the second part of this question is kind of like a pre and post thing, because you still have to analyze the program and say, okay, by the time we get to line 3, we know this for sure. Okay. So the best way to look at this part is really to look at App Inventor, but look at the source code of this code here. So line 3 is equivalent to this block here. So the question is, if I ever get to this block and about to execute this block here, what is it telling me? How do you think X, Y, and Z relate to each other? That's the question. Okay. But in order to get here, that means this condition has to be true, right? Because otherwise I wouldn't be here. I will be somewhere else. So in order for this condition to be true, that means Y is less than Z has to be true. Okay? But in order for me to even get here into this block, that means this condition has to be true. So that means X has to be less than Y, and Y has to be less than Z in order for me to get here. Now, you don't have to say, oh, but if X is less than Y and Y is less than Z, that implies X is also less than Z. I do not need all the implied true statements. Okay, you just need to tell me the basics. Okay, so in that case, if I need to answer that particular question, is line 3 the condition for me to get to line 3, or what I know for sure how the variables relate to each other, is X has to be less than Y and Y has to be less than Z. That has to be true.
Do we have to say K equal 1 too?
K equals to 1 is kind of like an after effect of that line, but if you want to add it, that would be okay. Okay. But it's not necessary, because I'm asking, how do I get there, but not quite. Once I get there, what has to be true after we execute that statement? Yep.
So you won't knock us points if we say k equals to 1. If we do say it.
I would not take points off if it is k equals 1.
Yeah.
But if it's k equals 1, I would take points off.
Okay.
Because this is a C and C++ class. The state k has the value of 1 is different from saying k gets the value of 1. So in this class, I will pay attention to double equal versus a single equal. Yep. So you have to be careful about that one. Okay. So if that is the effect of that's what we can conclude on line 3. Let's check out the other lines too. What about line 5? In other words, what about this line here? This line k equals 2 is equivalent to this block here. Okay, so how do we get here? X is less than y is true, and then y is less than z is false. That's all we know. Okay, we don't know exactly whether they are the same or y is greater than z, and we don't know how x relates to z either. All we can say is y is not less than z. That's all we can tell. Yep.
And that would be enough to answer your question
Yes.
for line 5? Okay.
So for line 5, the conclusion is we know for sure x is less than y, and we also know for sure that it is not the case that y is less than z. You can also say, instead of using this, you can also say y is greater than or equal to z. That will also be considered 100% correct. Are there any questions about this one? No questions? Let's talk about the other line. Okay, the next one is line 8, which is this statement here. Now this one is the then branch of x equals to y, but that is the else branch of x is less than y. So we know that x is less than y has to be false, x equals to y has to be true in this case. So we'll get to line 8 and say x is less than y is false, so it is not the case that x is less than y, and it is the case that x equal to y. We don't know anything about how y or x relate to z in this case because there's no comparison in the path to get to line 8 that can tell us anything about how x and z or y and z relate. Now for those of you who want to do the simplification, which is optional in this case, is how can we simplify this expression? It is not the case that x is less than y, and it is the case that x equals to y. Can we simplify it? How do we do it? No, it's just x equals y. Okay? Because x equals y is more specific than x is greater than or equal to y. In the case of a conjunction, we take the more specific one. But the simplification is not required. So if you think that you might run the risk of doing the wrong simplification, don't do it. Just give me this, and it's 100% correct already. Okay, now we have the last one, which is line 10. Line 10 is right here. K gets a value of 4. That is the else branch of the inner conditional statement. It is also the else branch of the outer conditional statement. So both conditions has to be false in this case. X is less than y has to be false to get to the else, to get to line 7. But once we get to line 7, x equals y also has to be false in order for me to get to line 10. So here comes the first question. Line 10, is line 10 reachable? Can we ever get to line 10? When x is okay, greater than, exactly, okay? Because not less than and not equal to gives you only one option left, right?
Yeah.
Greater than. Yep. That's the only time we can get to line 10. So that's the answer that I'm expecting out of question 1 of the mock exam. Yep.
Wait, so greater than is right. It's on the 10, right? And you just put x is greater than 1?
Yes. But that's after simplification. So, this will give you all the points already, and that's before any type of simplification.
So you mean we have to write that before we simplify it?
You don't have to, but if you give me just x is greater than y, and if that is the wrong answer, or if your simplification step is wrong, but you don't give me any excuse to give you points because okay, that's how I derive it from, then you cannot get partial credit. So it's always helpful to give me this first, and then you say that simplifies to x is greater than y. Then even if the simplification step is wrong, you still have the first step that is right. So if not all the points, at least we'll get partial credit. All right. Are there any questions about this particular one?
So,
Yep.
how you give the lines, you're supposed to just look at that line and examine what's going on over there. Like the fifth line, like how would you be able to get there? What conditions need to be true?
This one here?
Yeah.
Yeah.
You wrote the conditions right there.
Correct, because that's what the question is asking. The question is asking, not knowing the exact values of x, y, and z, indicate as completely as possible how the variables relate if code execution reaches each of the following lines. And so that means if I get to line 5, tell me how the variables relate to each other. Which one is smaller, which one equals to the other one. Tell me something about how they relate.
And I see that in the text box you put, that x is less than y, but you have to have and the other side.
Yes.
You have to have the other side.
Because at that point I can confirm both. Because on line 5, I can confirm that x has to be less than y, and it is not the case that y is less than z. Both of those conditions must be true by the time I get to line 5. If you give me one of the two, then I can only give you partial credit because I did in the question ask, tell me as much as possible. And if you miss some part of what you should know already at that point, then I can only give you partial credit. Any other questions about this? Yep. Right here, I'm reusing one of the older road sheets, so I just wrote a new column for today's date. All right, I'm gonna start with you here. Okay. So are there any other questions about question 1 of the mock test, mock exam? No questions about this one? Let's move on to the next. Sorry?
Let's move on.
Move on, yes, exactly. Let's move on to the second question. Second question is quite simple. This is the expression that you have to evaluate, but you have to tell me what happens to x and y in each step. Okay, so in each sub-expression, tell me what it is giving you and what is the side effect of that expression. Now, if I just give you this and ask you to tell me exactly what the code does, it's kind of brutal. So instead of doing that, I'm giving you an initial condition. In other words, I'm telling you, okay, assume x has a value of 4 and y has a value of 5 to begin with. Then you can track it, right? Because now you can actually plug in the values, apply the operators, and find out in each step what is happening. Okay? So read the rest of the question too. Okay, for simplicity, assume the variables are 4-bit integers because if you use 32-bit representation, the bitwise, not bitwise not, but the exclusive OR operator is kind of tedious, right? I mean, you have to write a whole bunch of zeros and then a whole bunch of ones, for no particular reason.
Kind of like how in our quiz.
Yeah, the quiz.
Kind of what?
Kind of like how in our quiz.
Yeah, well, that's only 16-bit, right?
Still a lot of zeros.
But in this case, assume they're only 4 bits, so it's a lot easier, right? There are only 4 bits that you have to deal with. Show all steps, including the evaluation of each operator. We have 3 operators here. 1, 2, and 3. Okay? For all operators, indicate the value of the operator. In other words, what is the value of this entire expression? What is it giving you back? Okay? If an operator has a side effect of changing, affecting, updating a variable, indicate that as well. Is a variable getting updated by an expression? Now in C and C++, assignment is an operator. As a result, an expression can potentially change a variable. Okay, that factor does not need to be considered in Visual Basic and some of the other programming languages. But in C and C++, because assignment is considered an operator, then an expression can change the value of a variable. So you have to tell me if that is the case, something is changed. Show all steps in the order of occurrence. In other words, step by step, tell me this expression gives me a value of this, and it is changing this variable to that. Okay, that's what I'm asking for. Yep.
Can we draw an illustration?
You can certainly draw illustration here. Okay, so I will attempt using a text editor. Okay. See, I come from a different era where graphical user interface is not, common. So I learned how to do most things in text. Okay, so what I'll do is I'm gonna re-express exactly the same thing here. Okay, and you can do a copy and paste, on your own too. All right. So what I'll do is I will say, okay, what am I evaluating first? Okay, if you just look at how the parentheses are nested, that will tell you what needs to occur first, right? What needs to occur first? Y caret equals X has to occur first because it has the innermost parentheses, right? Okay. So let's go ahead and deal with that one. Okay. So first of all, what is it really doing? Well, this is the same thing as Y equals to Y caret X. It's the same thing. Okay. So if that really is the same thing, what exactly is Y caret X? Y caret X is Y exclusive or X, right? What is the value of Y? It's 5 in decimal. In binary, it's going to be 0, 1, 0, 1. Okay, so we have 0, 1, 0, 1 here. Exclusive OR with 4, which is 0, 1, 0, 0. Is that okay? And with each bit position, we have to perform an exclusive OR, which means if it is 0, exclusive of 0, what is the result of that? That's just a 0. If 1 exclusive or 1 is a 0, 0 exclusive or 0 is a 0. Oops. And 1 exclusive or 1 is a 1. Very good. Okay, so now we are updating Y to 1. So as a result of this, Y basically gets 0, 0, 0, 1 in base 2. So the way you report this is to say value of the expression is 0, 0, 0, 1, and also Y is updated to 0, 0, 0, 1 in base 2. In this particular question, if you show me like 4 digits and they're all zeros and ones, I can kind of say, yeah, it's understood they're all in binary, okay? So you don't need a subscript of 2 or a parenthesis of 2 to indicate the base. It is kind of implied. Okay, so that takes care of the first one. Now we can take care of the second one. The second one, which is one level out, is X exclusive or whatever the result was, right? That result was 0, 0, 0, 1, which is the same thing as X equals to X exclusive or 0, 0, 0, 1. X itself has a value of what? 4. It has not changed, right? X has not changed. We changed Y, but not X. Yeah. So X is still the same as before, which is 1, 0, 0 in binary, 0, 0, 1, 0, 0. So we now perform the exclusive OR of these two numbers. 0 exclusive OR 0 is 0. And then now the next digit is 1, exclusive OR 1 is 1. 0 exclusive OR 0 is 0. 0 exclusive OR 1 is 1. So the conclusion is the value of the expression is 0, 1, 0, 1, which is 5 in decimal. And the side effect is X as a variable is now updated to 0, 1, 0, 1, which is 5. Are we still doing okay so far? Now we move on to the outermost operator, which is now y exclusive OR equal to the result of the expression, the inner expression, which is 0, 1, 0, 1. So that's the same as y equal to y exclusive OR 0, 1, 0, 1. And here's the trickiest part of the entire question. What is y at this point? Exactly. Y is now 0, 0, 0, 1 because it was updated 2 steps ago. Okay? So that's why you have to now write down 0, 0, 0, 1 exclusive OR 0, 1, 0, 1. The rest of it is kind of mechanical. 0 exclusive OR 0 is 0. 0 exclusive OR 1 is 1. 0 exclusive OR 0 is 0. 1 exclusive OR 1 is 0. So the result is the expression, the value of the expression is 0, 1, 0, 0. And the side effect is y is now updated to 0, 1, 0, 0. Okay. So now we got all the details figured out. But if you look at the entire thing, what do you think this operation is really doing? Exchanging the values of x and y. Right? If you look at the initial condition versus what we have now, y started off with a value of 5, right? X started off with a value of 4. Now they are opposite. So in C, to exchange the values of two variables can be done this way. Is it the best way to do it? Probably not, because it's really cryptic, but it can be done. Yep.
No, yeah, I was just gonna bring that up, like in that what we call switch
The swap operation.
Yes, thank you. Swap operation.
Yeah. In a classical swap, algorithm, you need a third variable as a temporary variable to store the value of one of the two while it is being changed.
Right.
But in C and C++, because the assignment operator, because assignment is an operator, you can do something like this. That is the reason, because you can actually store, quote unquote, the intermediate result as a part of the expression itself. And exclusive OR is also useful because it is actually a, there are many names to call it, but it's kind of like a self-restoring thing. You get back the original thing when you do it a second time. Right. Any questions about this particular answer? And this is kind of what I would expect, of you, from your answer. I would say that this step is kind of optional, but without this intermediate step, it's really hard to express this part. So I would still, look at the operator like this and translate it into this first. Okay, it just kind of makes sense to me. And by the way, what is the name of this kind of operator? There's a name to that. It has to do with assignment, but there's a special name to it. It's a compound assignment operator. Because instead of just doing assignment, it's also combining the operation, one computation step to it. So that's why it's called a compound assignment operator.
You have a third one in there?
Huh?
Like 3 of them?
3 of them?
Yeah.
What do you mean?
Like exclusive OR equals like plus.
No, you can only have one.
Or 2? Or
One.
One or the other?
You can only have one operator next to the assignment operation. All right. Any questions about this one? Questions? Right. Sorry?
Do we have to indent?
Indentation makes it easier for me to say this is the part corresponding to this portion. As long as it is clear, you can, if it's on a piece of paper, you can just do a kind of bracket thing and then use a pointer to say, okay, this is the calculation here, and then that's the calculation over there, and so on. As long as it is clear to me, how you get the beginning value and how you end up with the end value. All right, moving on to the third question. Okay, this is the third question here. This one is actually the kind of easier one. Okay, analyze the following code. Show how variable x is updated. For each update, every time you change the value of x, indicate the new value of the variable. You can safely assume variable I and x are already declared as integers with sufficient width, meaning the number of bits, to store the values. Use one row to indicate each update of variable x. Okay, so on a piece of paper, each line would indicate one update of x, and you have to do it in the right sequence. Alright, so how do we do this? So what you need to do is to understand exactly how this code is going to execute. The first update of x is here. That's the initialization code. It happens before we enter the loop for the first time. So you would basically say x equal to 0 is the first update. Okay, that's automatically telling me that x gets a value of 0. The second update is here when we get into the loop, because I started with a value of 0. So I plus plus is less than 3 is true the first time. So the next time is x plus equal to 1, which means x gets a value of 1. Okay, x becomes 1 because x was 0 before, and then you now add 1 to it. After this statement, it goes to the post operation, which is to add 1 to I already. So I becomes 2 before we come back here and compare again. 2 plus plus, or I has a value of 2 already. I plus plus is less than 3. Is that true or false? Is this a pre-increment or post-increment? It is the plus plus is after I, so it is a post-increment. As a post-increment, what I use for the compare is the value of I before this particular increment. 2 is less than 3. So the expression is actually true. Except by the time we get here, I is no longer 2, it is now 3. So the second update is x plus equal to I, but I has a value of 3 at that time. And because I had a value of 1 to begin with, we're adding 3 to it. X becomes 4 in the second update. After the second update, x already has a value of 3, but we are going to increment it anyway. So it becomes 4. So now it becomes I plus plus, which is 4 is less than 3 is false. So we get out of the loop. But when we get out of the loop, what is the value of I at that point? I would have a value of 5. Okay.
Even though it doesn't go through the loop, it still gets. Oh, okay, never mind.
No, it does not, because when I has a value of 4, I plus plus as an expression is already returning 4. 4 is less than 3 is already false, so we get out of the loop. But that did not stop this increment. So I would still be incremented to 5 by the time we get out of the loop.
But it would do that plus plus I over again.
But it would not do that plus plus I, because that plus plus I only happens when you're done with the body of the loop. So you have to look at the equivalence of a while loop and a for loop. So if I give you a for loop, how to use a while loop to do exactly the same thing, that's the one piece that you need to kind of go over.
So x equals to 0, that's where you start the loop.
Yeah?
I equals to 0.
This is the code that goes before the while loop itself. If you convert a for loop into a while loop, this is the stuff that you do before you get into the while loop the first time.
Okay. Yeah, I was looking at the commas instead of the semicolons, but now. Yeah.
Well, they're all different. Yeah, you have to differentiate. A comma is an operator. A semicolon is a statement terminator. So they're different. Yep.
What's the difference between a pre-increment and a post operation as opposed to a post-increment?
The value of the expression is different. The side effect on the variable I in this case is the same, but the value returned by the expression is different. I plus plus is saying the value of the expression is the value of I before the increment. plus plus I is saying the value of the expression is the value of I after the increment. So that's why they are slightly different, but in this case it makes all the difference because the comparison is using the value of I before the increment. Because if you use the other one, then you will miss one iteration. Right, so that's the third question. And moving on to the last one, which is question number 4. Question number 4 is the only one that you can really utilize your creativity. The other ones are kind of boring. You just got to follow the programs. Click, 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 like that one. This is the first one where you need to write some code. So assume that you are given several initialized variables as follows. B is the begin value. It is inclusive. It is a non-negative integer guaranteed to be at least 2. E is an end value. This is an integer guaranteed to be larger than B. F is a factor. This is an integer guaranteed to be at least 2 also. And counter is just, well, a counter. It is initialized to 0. You are also given a variable, this time uninitialized, which is x. Write the code to count the number of integers between b and e inclusively, which means you have to consider b as a part of that range and e as a part of that range that are divisible by the factor f. There's no need to declare any of the mentioned variables because, as I told you, they're already declared and initialized, assuming they're all declared. You may also assume the initialization is already done for the initialized variable. So you don't have to say, b equals to some question mark and so on and so forth. It's already done by the time it gets to your code. Your answer will be graded based on syntactical and semantic, which is the meaning of the program, correctness. Okay, so here you have to write some code on the fly, during the exam. Okay, so how do you do something like this? There's no one single correct answer. There are many ways, well, I wouldn't say many, but there are several ways to approach this one.
You start with the for loop.
Okay, start with a for loop. Okay, so what do we do next?
B is the beginning value, B is the end value, and then we...
Okay, they're already initialized. So what do you do next? X is a counter. Now, I didn't say that you cannot change the value of B or E. Okay, so you can change one or the other so they can keep track of which number I'm dealing with, right? So what do you do next? Let's just say that you're changing B, okay? So every time you process a number, you move B forward, okay? So how do we know we are done?
Doing B equal E.
But remember, it's supposed to be inclusive. In other words, if E equals to, let's say, 25, I need to take 25 into consideration. I cannot just go to 24 and say, we are done, okay? I have to consider 5. I have to count 25 in as well. How about when B is greater than E? Because when B is still the same as E, that means we have one last number to consider. When B is greater than E, then we are done. Okay. After each iteration, what do we need to do? We need to bump up to the next number to process. What is the next number to process? Plus plus B, B plus plus are both equal. They're the same here.
Wasn't it supposed to be divided by?
No, this is a post operation. We have to do this for each iteration. Okay, now we have to specify what is inside this loop here. What do we do in the loop? For each iteration, the number that we're considering is B. So how do we check whether B is divisible by F? And if so, we increment X by 1. If not, we don't touch X.
F modulo.
What kind of statement would be useful here? Huh? Mod expression would be useful, but what kind of statement would be useful here?
Percentage, and if it divides, and if it's either 1.
Okay, you're still talking about operator. Okay, what statement would be useful here? Certain times I need to do this, other times I need to do that. Conditional statement, if statement, very good. So let's stash an if statement here. And every time I put an if statement here, I always start with all of these potential places to put in something. If there's nothing to put there, that's fine, okay? But I'm always going to say, okay, what if there's something to put there? what kind of condition are we talking about here? Divisible. Whether something is divisible. Do we have anything that can tell us whether a number is divisible by another number? The mod operator. Very good. So we stashed the mod operator here, but the mod operator needs two values to process, right? So what do we specify on the left-hand side? What do we specify on the right-hand side?
B and F. B and F.
B on the left and F on the other side. And what do we do with this?
Has equals 0, yeah.
Checking whether it equals to 0. Okay. So remember, not this. Okay. You gotta have double equal in this case because we are comparing for equality. We're not changing the left-hand side. And if it is 0, what do we do?
X plus minus.
X. We can do a simple plus plus x here, or x plus plus, x plus equal to 1, x gets x equals to x plus 1. They're all acceptable answers. Okay, I'm not looking for the shortest notation. Just give me something that works. Okay, that's it. That's the entire program.
You don't have to put anything directly
For the
after
else?
your first parentheses.
No, because they're already initialized. Oh, you're right. Okay, I forgot one thing. Okay, what do I need to do here?
Plus X.
Initialize x. The only variable that is uninitialized. Yep.
What does it say?
Actually, I take it back. I forgot. It's supposed to be counter, not x. Okay, so we have to. Sorry about this. So to use x, the intention of x is this. That is supposed to be x, but I use b instead. So I'm gonna change all that stuff to use x here. And counter is already initialized to 0, so we just say put counter here. I'm sorry about this. I forgot about my own question. Okay, because x is a uninitialized variable. Its purpose is to keep track of which number we are processing. Counter is already initialized to 0 before it gets to your code, so you can just add 1 to it every time you find a multiple of f. Yep.
So over here, it starts with B and it ends with E. And every time you do a step, you add okay, yeah, that would make it go one step, plus X. And then you do the if statement in the middle.
Oh, so I have to do this part here. As long as x is less than or equal to e, we stay in the loop. Yep. Okay. Otherwise, it's okay. We just get out almost right away because it's not greater than. Yep.
What do you mean correct the other way?
Hmm?
The X is 0 and B is 0.
Yeah, that would also be correct, but you're not changing counter. You have to. You will need a counter equals to x at the end after the loop to make it correct. Yep.
So why don't we need an else?
Sorry.
Why don't we need an else statement?
We don't really need it in this case. I just put it there automatically. Yeah. That's one way to do it. Yep.
Will notes be allowed for this test?
Sorry.
Will notes be allowed?
Oh, that's a good reminder. It is open book and open notes. Okay, if it is a paper test, that means you will have to bring everything in a form of either written or printed form.
Nice.
So you cannot use a computer during the test if it is on paper, which is probably the case because we don't have enough computers for everybody in this class. So it's going to be a paper test. If it is a paper test, that means no one can use a computer or an electronic device other than a simple calculator. And just like last semester, I will bring my dumb, Dollar Tree calculator in case anyone needs a machine to perform addition, subtraction, or whatnot. So if you need a calculator, I will have ones to loan to you during the test. You can actually buy scientific calculators for $1 at the Dollar Tree.
So cheap now.
Yeah, it's like wow, it's you can keep a few at home. If you occasionally just destroy one by dropping it and step on it, okay, there goes another buck. Go home, pull out another one. It's okay, I'm good again. Just stack up.
Yeah.
Yep.
So I'm quite understanding. I just don't understand quite what's counter.
Counter is there to count the number of numbers between B and E that are divisible by F. Yeah, that's the purpose of counter. Oh, I didn't explain what counter is for. Okay, that's my fault as well. Yep. Yep.
Can you save that file so I can practice at home and then use that for the answers?
It's all being recorded.
Oh, yeah. You forget it.
Yep, take a screenshot and.
Yeah.
But this is not the only way to do it. Let me show you another way, or one of the many other ways to do this. Okay. Another way to do this is to use a single while loop here. And with a while loop, you still need the initialization. So the initialization of x equals to b has to happen before the while loop. But then you can also just use a while loop here. In this case, you can use x is less than or equal to e. Has to be the condition. And then inside, you can use the same conditional statement, and then followed by x plus plus after that. So I'm gonna give you the most obvious answer first. Okay, so this is the most obvious answer. It's basically converting a for loop back into a while loop. The initialization is before the loop. The condition to stay in the loop is the condition itself. The post operation is what you do after what you want to do normally in the loop here. And then the body of the loop, which is only really this part here, is the same over here. But the conditional statement has another way. There's another way to express this conditional statement. So let me give you the other one, which is using a ternary operator in this case. So the way to use a ternary operator is basically to say, I'm going to add one to counter. Okay, counter plus equal to something all the time. But whatever is whatever you're incrementing depends on a ternary operator. The ternary operator would look at x mod f and see whether it equals to 0. If it does equal to 0, it will give me a 1 to increment. If it does not equal to 0, it will give me a 0. Because plus equal to 0 is not going to change anything. So that's another way to do it. Okay. And here's another version of this. Okay. Another version of this is not to compare to 0 at all, because x mod f will return the remainder of x divided by f, right? What if that remainder is a non-zero? If that remainder is non-zero, this expression is considered to be true. But if the remainder is non-zero, I don't want to increment the counter, so I can put a 0 here. If the remainder is 0, that means the expression is false. And in that case, I do want to increment the counter by 1, so I can do it like this as well. Are we still doing okay so far? Okay. This is considered as an expression, but this expression is considered to be a condition. A condition in C and C++ is really a matter of saying, is it non-zero? If it is non-zero, it's the same as a true. If it is 0, it is the same as a false. Is that part okay? You guys still remember that part? Okay. But x mod f is just the remainder of x divided by f, right? So if the remainder of x divided by f is 0, this expression is going to be a 0. But if this expression is 0 in terms of Boolean expression, it is considered to be the equivalent of false. If it is false, then in a ternary operator, the last component is returned. In this case, it is a 1, which means we're adding 1 to the counter, which is what we want to do. Because in that case, x is a multiple of f. Is that okay? And if x mod f is non-zero, that means it is equivalent to true. If the expression is true, we do not want to increment counter, because x mod f being non-zero means x is not a multiple of f, so we don't want to increment counter in that case. And since we have 40 seconds or so, I'll give you one last version of this. This plus plus x here can be absorbed into the other expression by using a post increment. Because we are always adding 1 to x for each iteration anyway, right? So we might as well just say x plus plus. Utilize the value of x for the mod operation before the increment. and then right after that, change X so it's one more than what it was. So that would be the same thing, but if you do it this way, we no longer need the open and close curly brace. So it's really the same as that, which is not a good idea. Okay, using the curly brace is a better way to do it, you know. But I'm just incrementally making this code more and more and more cryptic.
Thanks, appreciate it.
Well, I mean, it is important because, you know, in the process of making this code more cryptic, I'm really just revisiting stuff that we have already talked about. Okay, so even though you may not say, okay, you know, who would come up with, you know, cryptic code like this other than TAC? You may not come up with this code because it's just not natural to think that way, but you should at least be able to understand why I can go from one step or one version of the code to the next one. Because that is all, you know, we have talked about in this class. We have talked about enough concept so you can understand how we go from one step to the next. All right. So good luck with your homework assignment. Don't forget about it. I'll see you guys on Wednesday. Study for the test too.
What's the next?